Hacking mobile devices, this is the last class, and I'm just going to talk about the second half of attacking iOS applications. It's pretty much talking about terms without explaining in much detail because we don't have any hands-on projects to go with them due to the lack of an iOS emulators, which I can give students, which is a shame, but that's the way it is. We were able to use Android in the hands-on much more than iOS. So we talked about transport security and such last time, and this time it's attacking the runtime, inter-process communication, and injection, and this is essentially instrumenting with Frida and other tools. So to attack the runtime, what happens is, remember, Microsoft Windows software has this DIL process where you can dynamically load a library while you're running. And there's a similar thing in the runtime. It can, while you're running it, it can use something called reflection, so apps can dynamically load new classes while they're running. So that sounds pretty dangerous, but that's how it works. And so what you can do, because it's an object-oriented language, you can overwrite some of those objects and change what it does. So in object-oriented language, you have objects which have classes, and the classes have variables in their instances, methods, and properties. So you have an interface file that defines the structure of your class. So this is what you'd have in there. You'd have member variables. You have an interface like a book, and then you have things like data and pages, title and author. Then you'd have methods, get the title, set author, get author, and then the class method, create book with title, this sort of thing. Various layers of objects and methods and data stored in that object. So instance methods can only be invoked after you create an instance of the class. So if you've defined this thing called book, but you haven't actually made any books yet, then you can use the class methods, but you can't use the instance methods. So these exist, like create book clearly exists before you make a book, because how else would you make a book? These ones exist whether you have actually books or not. These only apply once you have made a book. Then for that particular book, you can do things like get title. All right, and in Swift, it looks like this, which is more the language that iOS apps are written in. You have a class, an instant variable, instant method, class method. It's just the language of how you do it. So you can instrument the runtime, where you analyze the execution of an app at runtime, like the debuggers we've used. And so if you do that, you can then modify how it runs by changing what the calls do while it's running. And then you can do things like bypass jailbreak exceptions, steal encryption keys, load view controllers, which is like what we did on Android, where we forced it to load all the visible pages of the app. Attack authentication, pivot to networks, imitate malware, inspect a custom encryption protocol. You'll be able to make the calls to encryption, print out the variables going in and out, that sort of thing. That's my understanding of it. Like I say, I don't have any hands-on experience with these things. So Objective-C is the language that's easiest to instrument, they call it. You pass it a message through the message send function, and you can simulate calls to that. So this is called method swizzling. This will replace the meaning of a method at runtime. So this is very much like the hooking the SSDT in Windows that we talk about in the malware analysis class, the service set descriptor table. What happens is you have a dispatch table which maps how to find the methods, and you can just change the pointers to point to other things, so it does the wrong thing when it calls the API. Swift is more difficult to do this to. Cydia Substrate is the main manipulation framework designed by Soric to create the App Store for jailbroken phones, Cydia. That's why when you jailbreak an iPhone, you get Cydia and you get the apps from Cydia. It's all working because of the Cydia substrate. This is how they hack the iPhones to jailbreak them. They change the meaning of the internal function calls with this instrumenting process. It's pre-installed with Cydia. You can also have substrate extensions where you tweak the Cydia substrate to customize your phone in other ways. And you can write your own code to customize it now in your control of the operating system. So your extension will be loaded into every new process unless you give it a filter which specifies what processes should get your extension. And so you'll have a plist here that tells it only to, this is the filter, so it will only install on things that have this identifier in them. So this is from the textbook, MDSec. There are environments just to develop these tweaks. You can customize your phone. iOS OpenDev, Theos, and Captain Hook are some of these frameworks to help you customize your phone. And here's some of the functions you have in the substrate: hook a function, find a symbol, get image by name, hook a message. These are obvious things to capture the messages being flying around in the phone and change them, modify them, intercept them so the phone behaves differently. So this hooks native C or C++ functions, and it uses a trampoline, which we've certainly talked about in the exploit development class, where you bounce off a predictable piece of assembly code to go somewhere else. Trampolines are used to defeat address space layout randomization. You don't know where the code is, but you find a place where it's jumping to the stack, so you arrange to put your desired code in the stack, and you jump to where there's a jump ESP, and then it finds your code wherever it is. And here's something that will find symbols if your app has the symbols, although most compiled apps have the symbols stripped away. But if not, then you can find symbols by name and look for things that are interesting, like password or whatever you're looking for in the app. This will load a dynamic library, just like a Microsoft DIL. And this is what implements method swizzling for functions that inherit from the object. So when the object-oriented code tries to call a function, you replace it with another function so it does something other than what the developer intended for it to do. Just like we did with Frida on Android. And you can also use Frida on iOS. It's coming up. So here's an example of these things. You have the stat is a function that tells you the status of a file, a very simple function in the command line Linux. And so here we define something called old stat here, which points to the original stat. And then we make something called new stat. And here's the method stat hooked, checking for bash. And what it'll do is if you try to stat bash, it will give you no answer. That's all this hook does. Doesn't do anything too great, but it will modify calls to stat. So now calls to stat will not work if you do them on bin bash. So that's all it does. And this MS initialize in line 15 initializes, loads the content, and MS hook hooks it, taking the symbol to replace is stat, replace it with new stat, and here's the old function. So that's how you do it. It's just like how you make a rootkit, and we talked about this in Windows environment too in the malware analysis class and the exploit development class. Cycrypt is another runtime instrumentation tool which uses JavaScript and Objective-C to do these things. It can brute force local authentication, steal encryption keys, force loading of visible pages of apps view containers. And of course, there's another. So now that you know, you can, if you jailbreak your phone, you can take it over this way and run one of these instrumenting frameworks and make your phone do things it shouldn't do. So this raises the issue of mobile device management. Now, everybody has to bring your own device. We've all gotten used to this. I just wrote a whole risk assessment of this for one of my clients recently. Almost everybody uses their home device to access company resources. That's just the way it is. Very few people are willing to make you carry two phones, which would be the only way to make it secure, have the company device and your personal device. But if you do have a device, then if you somehow get that phone compromised, then the attacker on your phone can get into the company resources. And that's an issue. Kaseya is an example of this. Kaseya launched their bring your own device management, which is now called mobile device management, is what this category class software is called, that makes your phone a slave to the company server like a domain controller and a Windows device. So the company server can push out policies like you can't jailbreak it, you can't install TikTok, you must have a 6-digit PIN, and things like that. And they can tell if you're out of compliance, and they can even remote wipe your device if they get really mad at you for being out of compliance. They say, you idiot, you're exposing our company data unsafely. But that means, of course, Kaseya Gateway, install Kaseya, you get the Kaseya secure browser, and now you can browse the internal folders at your company. And so if your phone was to get infected, the attacker could attack your company. And so nowadays, this is also true, of course, in Office 365. You have the modern, I'm looking a lot about this because of their AI product, Copilot. Microsoft 365 gives you Office 365 apps, and Outlook 365 email, and it gives you their Dropbox, OneDrive. So you have all your files stored in the cloud on the Microsoft servers, and you have permissions, and a tool can just look at all the files you have permissions to see. And I think the same thing would be true if someone was able to compromise that account. You'd be able to just harvest all your resources. And the problem with Copilot is that Copilot does that. It scans all your files, all your emails, everything you can reach in order to give you AI answer to questions. So when you're composing an email, like describe your new product or your progress report, it will scan all your emails and everything, and your Excel spreadsheets and everything, and make the answer. And the problem is you don't really know that that answer didn't include confidential stuff from an email that said, I'm telling you this, but don't release this until next month. It's not going to understand that part. It's just going to put it in there because it appears to be relevant. So anyway, I see a comment in the chat. If I can find the chat, here we go. Yeah. Does all MDM, yes, as far as I know, all MDMs do essentially the same thing. They give the company the ability to examine your phone and see if it meets the security policy and to remote wipe the phone. Those are sort of the bare minimum. You have a policy document on your phone. Now, you can set it up at different levels of ruthlessness. You can make it so that it will just warn you, or they can even forcibly install an app or forcibly remove an app, just like domain controllers can in a Windows environment. Your remote wipe, no, that's a very good question. In such a situation, would remote wipe only the company's info? And I think not. Remote wipe would just reset the phone to factory defaults. You would lose everything. This is why usually you only use remote wipe if you lose the phone. Then they wipe everything. And another issue, which it occurs to me, I forgot to include in my risk assessment, is what if you have iTunes backup turned on to the cloud? I think it would back up your company data. That's another risk. Your company data is now going to, of course you want that, because if you lose your phone, you buy a new phone, you bring the iCloud backup back, you want to be back at your company, but your company might want to know that their company data is now in the iTunes cloud under Apple's control, subject to them losing it and being subpoenaed and everything. That might violate compliance. I didn't think of that, and if I could, I would go back and add that to my risk assessment. That might actually affect my client. Anyway.
I think the iCloud cannot save other data than the music.
No, but there's iCloud does. iCloud backs up your whole phone. And Apple really wants you to do it. They'll keep harassing you if you don't have iCloud backing up your phone. Because if you lose your phone, you lose your pictures and emails and everything. But if you back it up to iCloud, you can just buy a new phone and put it all back. And that's what most people want.
So it's not iTunes, it's iCloud.
iCloud, right? Not iTunes, but iCloud. Yeah. Anyway, it's a very interesting issue. So then you have Frida, and Frida, which we've already used in Android, does all essentially the same thing, and you can use Frida on the iPhone. It doesn't use Substrate. You don't have to modify the device. All you have to do is run the Frida server binary, but of course you have to jailbreak the device to do that because it's not an approved Apple app. And so you can load a library into a process, another way to do it with a dynamic linker. So then there's inter-process communication. So iOS apps run in an isolated sandbox. They're not allowed to communicate with any other processes except a few ways. The clipboard, which they call the pasteboard, protocol handlers, and application extensions. So protocol handlers are just these things before the :/ in a URL. So you normally have HTTP and HTTPS and mail to and telnet. So you can define these. Here's the one that opens the App Store. I've seen this a lot because Apple, in order to comply with the European new law last month, that they turned on third-party app stores in Europe. And they had a new protocol handler for them that you could choose, and people were slipping bad character, making malicious third-party stores that would trick you. They were pointing out there was a vulnerability in the way Apple implemented this protocol for third-party stores. They already found a vulnerability, so we'll see what comes of that. Apple's whole point, of course, is that they want to charge 30% of all the money that goes through all the apps, and in return, they make your iPhone secure. And so they would probably like this third-party store that they're being forced to use to turn into a security disaster, as long as they could make it not their fault. Anyway, you can define a custom URL scheme in your app's info plist file, so you can define something like my VoIP for your dialer to make phone calls if you like. And so this happened to Skype, just like it happened to them on Android, that they had a Skype prefix, and you could put it in an iframe. So they could make a web page where simply viewing the web page would make a phone call from your phone without any user input. And of course, I think they patched this long ago. On Android, they patched it, so every time it makes a phone call, it'll pop up a box, do you really want to make a phone call? So this can't happen in the background by accident anymore. All right, then there's application extensions. Extensions that go to an app. So today is one from Apple that will connect it to the notification center, so these notifications pop up telling you, you just got an email, you just got an SMS message, share and custom keyboard or other ones. So if you have an app and you open a URL, so you go to, you read write to a shared resource, and the app extension can read from that, and it can then talk to the host app and get replies. So your extension can add functionality to the app. That's the idea, just like a browser extension. 1Password uses an extension. Now it would have to. If you think about your password manager has to feed your name and password into pages where you're logging in for you. It has to get them in there somehow, so it uses an extension to do it. So the apps can clear the credential. This, by the way, is a pretty terrible idea. What they really ought to use is OAuth. OAuth lets you make a request. If I'm trying to get you to log into my service and you're going to log in with Facebook, I can send an OAuth request to Facebook saying, this guy wants to log in. Will you please pop up a Facebook box? Let him log into you. I will never see the password. And then when he gets in, just send me like a cookie with only the information I'm supposed to have, which is typically your name, your email address, and like a cookie. And now I know you logged in, but I never saw your password. Only Facebook saw your Facebook password. Then they passed me an OAuth credential that lets me know you have in fact logged in and I know who you are. Now I can do whatever I'm doing, but I don't have to take responsibility for the password or the login. That's the right way to do it, in my opinion. That's a good way, but that's another way to do it is these extensions. So a malicious app could request credentials for any domain. Now they say users must manually approve the use of the credential, which is strange. And I don't think I've ever used a password manager on the phone except for the iCloud keychain. Now the iCloud keychain happens automatically. If I log in on my Mac, then my phone, if I go to that web page, will say, oh, I saw you log in on the Mac. I stored that password in the keychain. Would you like to use it? And if I approve it, it does biometric authentication. It has to recognize my face. So that's not too painful, and that's what you need here. So anyway. So then there's injection. So if you're going to inject code, any place you can feed data into the phone is a possible way to inject it. So web apps are obvious. Data on a web page, things in schemes, file types, AirDrop, beacons, Bluetooth, Wi-Fi. Any way that data comes in the phone might, in principle, make it subject to injection attacks. So now your UI web view shows not only HTML, but also PDF and RTF and Office documents and iWork, and you can't turn any of that off. So it renders all this content, PDF being the one that immediately catches my attention. So many PDF attacks have happened. A PDF is a very complicated format, and it actually includes all sorts of nasty things, and there are many times when PDF documents can be used to gain code execution. It also supports JavaScript, and you can't disable it, so in principle you can have cross-site scripting attacks possible if you don't filter the input correctly. And this happened to Skype. Skype allowed script injection into your name. So you could put script tags in your name, and then when people added you to like their address book or something, they would render your name, and then they could steal your address book and stuff like that. The kind of thing, very much like Bobby Tables. This is essentially what the Bobby Tables attack was. You put script in the name, and then when people type it in, it executes later when they use the name. Yeah, that really happens. XKCD is great. That guy doesn't write garbage. He researches. And his demonstrations are usually quite correct. So, all right. And then you can inject into the SQLite databases. I mean, you have a database, and it's SQLite, and it's vulnerable in principle to SQL injection if you don't filter things. So if that happens, typically all you get to do is steal the data. You don't get command injection, but still, that's not good. And then, of course, XML injection. If you can do XML entity injection, the most common thing is a DOS attack. You define XML external entities, and you can easily make an external entity like a zip bomb that will just turn into a monstrous amount of computation and data so that it freezes up your phone. But you could also use it to send signals on your local network to other apps and see if they're there, sort of do port scans and things like that. And if you have any app that uses a file name, then you're subject to directory traversal if you don't filter things, which is an attack from the 90s or 80s, but it's all come back. It's come back so badly that the CISA last week had an official announcement, will you guys please patch your stupid directory traversal attacks? Many people are falling for it again, where you just take a file name and you put in .. / path to where I'm not supposed to go. And it goes and lets you read that file or delete that file or run that file, which you were not supposed to be able to do. it keeps on happening. So you can upload a profile pic to document Joe pic, but if I change the name to /Jane pic, then I'll change Jane's pic instead of Joe's pic. And it used to be in the days of Windows NT in like 1995 that if you ran a Microsoft Windows web server, you could just go up to the URL up here, and you could just type // Windows System32 cmd.exe. And you would get a command shell right in the browser. And I saw this in a movie, and I said, that's bullshit. You can't just do that, but you really could do that in early versions of Microsoft products. You could just do a directory traversal from the location of web pages to CMD and run it, and it was bloody awesome. So that's the kind of thing that has been fixed long, long ago, but every app that uses a file name has a chance to make that mistake again, and they are making that mistake again. So, all right. Anyway, let's take a look at a Kahoot, which is here, the last Kahoot of the semester. All right, so how do you define a class structure? Java programmers probably know all this stuff. That's an interface file is what defines the class structure. All right. All right, where do you find pointers to methods? Dispatch table, this is a really common issue. You can hack the thing by changing the pointers in a dispatch table. In Windows kernel, you hack the SSDT to make rootkits. And in Linux, we do it in the exploit development class. There is a similar table that points to all the C library methods, and you can modify that table and get in. They call it the relocation records there. Anyway, it says every operating system uses some kind of pointer table, and if you can write to that, you can hack the system. All right, which plist file controls when an extension is loaded? That's the filter. And I think the same thing in Android. There's an intent filter, which serves a similar purpose. All right, what tool blends JavaScript and Objective-C? It's easier than I thought. I didn't make it too hard. I made it easy to exclude. Yeah, Cycrypt is the only one that comes close. These others are very different things. That's all right. That's a substrate type framework to control the phone. And which one always allows JavaScript? Web views. To display web pages in your app, it always allows JavaScript. This kind of, I think this fits the Apple philosophy. Rather than letting you turn it off because it's dangerous, they would say, no, everybody wants it, run it and make it safe anyway. That's the Apple way. Anyway. Like, Windows has all this system restore and everything, and when they tried to put it in Mac and iOS and OS 8 or 9, Steve Jobs said, no, just make it so it doesn't crash in the first place. Don't have some kind of repair tool on there. That's idiocy.